Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over how to explain why all the six atoms in a molecule are in the same plane or not. So let's get into this. So in this question we're asked, why must all six atoms in C2H4 lie in the same plane? So first of all, we need to write the Lewis dot structure. So let's start with that. So the Lewis dot structure, since we have two carbons, carbons are going to be the central atoms, and then the two hydrogens are going to be evenly distributed among the two carbons. So we have carbon bonded to carbon. We're going to have two hydrogens on this carbon, two hydrogens on this carbon. And each carbon only has three bonds, so you need another bond. So that's going to be a double bond between the carbons. And there's our Lewis dot structure. And so the next thing we want to do is kind of look at the hybridization among the two carbons. So hydrogen is going to have non-hybridized orbitals because hydrogen is only bonding once. So no hybridization is needed for hydrogen. But you'll notice that each carbon is bonded to three atoms. So you have 1, 2, 3 electron groups. Double bonds are not considered two electron groups, it's one electron group, even though it has two pairs of atoms. So this is considered one bond or one electron group. And then you got the two hydrogens, so three electron groups. So for each electron group, you need an atomic orbital to be hybridized to get three equal energy hybrid orbitals. So just to kind of show you what I'm referring to, so you have here, you have like say the 1s, or so in this case you have the 2s orbital, and then you got three 2p orbitals, and then you've got 1, 2, 3, 4, 5. Well, we're not going to have d orbitals, but you know what I'm saying. So if you have d orbitals, they would be there. That would be there for the 3s and the 3p, but we're not going to have that for carbon. So what we're going to do is, since we have three electron groups, we're going to need three molecular hybridized orbitals so that those electrons can be involved in bonding according to the theory, according to valence bond theory. So then what we're going to need to do is we got to take the atomic orbitals. So these are atomic orbitals. And we're going to need to take the number of atomic orbitals that we need. So for every electron group, we need an atomic orbital to be hybridized. So since we have three groups, we need three three orbitals. So that means we're going to always start from the lowest energy and work our way up to higher energies and take what we need. So since we need three, we're going to need one of these, right? So we're going to need, let me use a different color. So we're going to need this one here, and we'll need two more to get three. So we'll need two of those. So we'll need those three. And then when we take, I should draw that clearer. I don't know if you can see that very well on my board. All right, so then we're going to take these three, and we're going to get three equal energy sp2 hybridized. Why sp2? Because we have 1s and we're taking two p orbitals, so that's 2. So we call them sp2 hybridized orbitals. And so they're going to be equal energy somewhere between the s and the p, right? So we'll have 1, 2, 3. So this would be sp2 hybridized. So 2 sp2 hybridized orbitals, all equal energy. And then you'll notice we have one p orbital left over. That's important to keep in mind. So we're going to have a p orbital, unhybridized p orbital left over. These three equal energy sp2 hybridized orbitals are going to involved in the bonding between the atoms. Okay, so here we'll have sp2 hybridized for that carbon, and the same thing for this carbon. So if we call this carbon 1 and carbon 2, this would be for carbon 1, right? So let's say carbon 1, and then same thing for carbon 2, right? So for carbon 2, I would also have a 2s and 2p orbitals. And once again, because this carbon here has 3 electron groups, you're going to need to use 3 atomic orbitals, hybridize them to get your molecular orbitals, right? And so, again, we'll take those 3, hybridize those, and again, you're going to get 3 equal energy orbitals. So 2 sp2 hybridized orbitals, and then you're going to have 1 p orbital that's unhybridized left over. So again, you're going to have 1 unhybridized p orbital. And so this is for the second carbon, carbon 2. This is for carbon 1. And so what's going to happen is for those carbons, right? So the carbons, each carbon has 4 valence electrons. So you're going to have those electrons are going to pair up with other electrons, with the electrons in the 1s orbital. So each hydrogen just has an unhybridized 1s orbital with 1 electron in it. And so in this case, you're going to have, according to valence theory, these are going to have 1 electron. Each of these is going to have 1 electron. And the 4th electron goes into the p orbital, like so. And so then what's going to happen is the unhybridized orbital for the hydrogen is going to overlap with one of the sp2 hybridized orbitals on each of the carbons, right? They're going to pair up electrons. You're going to share those 2 electrons now between the atoms. And so that's what's kind of going on here, right? So then you get what are called, right? These are going to be overlapping orbitals here between the hydrogen and the carbon, and between the 2 carbons, right? And so the orbital overlap is going to be along the axis, right? So directly along the axis, directly between the 2 atoms, and that's what we call a sigma bond, right? So the overlap of the sp2 with each other, so you're going to get an overlap between these. So if I draw like hydrogens here, right? So if I have 1 hydrogen with a 1s, oops. So there's a 1s, and then here's a 1s for this hydrogen here. and then you have another hydrogen with 1s, with 1 electron, and so on. And so what's going to happen is, well, carbon number 1 has an overlap, right? It has 2 hydrogens bonded to it. So you can take this electron here, pair it with that electron, so this orbital and this orbital will overlap, right? That'll create a sigma bond, because that overlap is going to be along the axis between the two atoms. Then this hydrogen here will pair up with a hydrogen in another sp2 orbital on the carbon 1. That's going to create another sigma bond. So we have those bonds there. And the same thing with this carbon as well. So you'll have 2 other, right? So here's one that could pair up with that one there, forming a sigma bond. And then the last one here could pair up with that one, forming a sigma bond, right? And then you've got these 2, that could be the overlap of the 2 carbons, right? Because we have the 2 carbons here. So they're also going to need to overlap. And so you have an sp2 with an sp2. Those electrons can pair up and overlap, and that's going to be between the 2 axes. And so that's going to create a sigma bond, right? But then you have this unpaired electrons here, and the unpaired electrons there, unpaired electrons in your unhybridized p orbitals, that can also overlap, right? So these can overlap, forming a bond, but this bond is not going to be along the axis. It's going to be outside the axis, forming what is called a pi bond. So we have sigma bonds that are along the axis, and the bonds that are outside the axis are going to be pi bonds. So this is kind of an overview of like the background and understanding what's going on. So now I'm going to draw a picture to kind of help show what's going on with the overlap. So I'm going to try to do it down here. So here I have my carbons. Okay, so I have 2 carbons, and I'm going to try to use different colors. Hopefully this will work out. I'm not a great artist, but first, you got your 3 sp2 hybridized orbitals. Again, you have 3 electron groups. If you remember from Vesper theory, if you have 3 electron groups, no lone pairs, then the shape or the molecular geometry is going to be the same as the electron group geometry, and in this case, it's going to be trigonal planar, right? So if I erase this, give myself some space. So we're going to have a trigonal planar arrangement of the 3 sp2 hybridized orbitals. So we'll have 1 here, and then again, this is going to be trigonal planar, so bear with me. It's not gonna be pretty. I can make that one a little better, I think. So here we go. So there we go. Let me make this one a little better. Okay, that's as good as it's gonna get. So then these are your 3 sp2 hybridized orbitals, and this carbon is also going to have sp2 hybridized orbitals. So here we're going to have overlap there, and then the 2 here are going to be this way here. Okay. Now, this is all in the plane of the board because we have trigonal planar here and we have trigonal planar here. So if I complete this, so if I now do the hydrogen. So the hydrogen is going to be, so this is sp2 hybridized orbitals. So the green here is all sp2 hybridized orbitals. And then if I use orange here, there's going to be overlap of the sp2 hybridized orbitals with the unhybridized orbital of the hydrogen. So this is going to be your hydrogen here, right? So there's your hydrogen, here's your hydrogen, here's your hydrogen, and here's your hydrogen. And so we can show, so then this is going to be your circular 1s orbital overlapping with each of the sp2 hybridized orbitals. And so this is in the plane. Now, where do these come in? So the thing you have to remember is that the p orbitals, remember, all three p orbitals are at right angles of each other. They're perpendicular to each other. So remember, you have the px, which is along the x-axis. So if you think of the x-axis as this way, then the y-axis, the py orbital, is along the y-axis, which is, again, perpendicular to the x. So perpendicular, right? And then you have the z, the pz, which is the z-axis. That's going to be perpendicular to the plane. So it's perpendicular to these two. So if you think of a Cartesian coordinate system, right, like so. So here's your x, here's your y, and then your z would be coming in and out of the board, right? So something like that. So all three axes are perpendicular to each other, so p orbitals are perpendicular to each other. So that means that these unhybridized p orbitals are perpendicular to the plane. So they're going to come out of the board. So if I can use a different color, maybe I'll use red. Maybe red will be clear. So then if I have the p orbital, it's going to go into the board and out of the board, like so. Don't fault me for my drawing. And if this one goes, oops, that's really ugly. So let me do that again. Okay, so then this one will go into the board, this one will come out of the board. And so basically, as best as my artistic ability is going to be, so the red will be coming out of the board perpendicular. And so then you get this overlap between these guys here that are going into the board and between these guys here coming out of the board, and that's your pi orbital. And the pi orbital is going to keep the bond from rotating, right? So if there was no pi orbital, if these two unhybridized p orbitals were uninvolved or not involved in bonding, then you would have just a sigma bond here, a single bond, and then you'd be free rotation. But because you have these unhybridized p orbitals that are going to overlap and share the electrons, forming a pi bond, that pi bond is keeping everything in place. So the two hydrogens here and the two hydrogens there are all in the same plane as the two carbons here. So these two carbons are in the same plane. And since this is trigonal planar, and this is trigonal planar, they're all going to be in the same plane, and there's not going to be any rotation because of the pi bond that's holding it in place. And so that's how you know, that's why all 6 atoms must be perpendicular, or I'm sorry, must be in the same plane as each other. And so that's it for this video. I hope this was helpful. Sorry about the drawing, but I hope that it was enough to clarify or help you understand this question. If you enjoyed this video, if this helped you out in any way, then by all means, like the video, share the video, hit that like button somewhere over there somewhere. I know you can find it. Also, do me a favor, subscribe to my channel, hit that notification bell. When you do, click all so you can be notified by all the videos I put out. Help me out, man. Support the channel by doing that. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a particular question or problem you need help with, or a topic you want me to cover, let me know. I would love to do that for you. Thanks for joining me, and have a great day.